In this lesson, we're going to be solving quadratic systems. And so some of our equations are going to be quadratic, some are going to be linear. Our quadratics are going to have an x squared term. Our linears are either going to be just a number or it's going to just have an x term. So for this first example, I've already graphed it here. The quadratic is the red curve and the y equals 6 is the horizontal line. And so just like with linear systems, our solutions are the intersection points. And so in this case, we have negative 0.6 repeating for the x coordinate and 6 for the y. And so negative 0.6 repeating is negative 2/3. And so one solution for this curve is negative 2/3, comma 6. And the other solution is 1, 6. Okay, and then whenever you're solving a system with x and y, you need to report both as your solution, both ordered pairs. And so the two shapes here are a parabola, which is the U shape, and a line. And so our solutions end up being negative 2/3 and 1/6. And so you're not always going to have a calculator, and so we have to be able to solve this without graphing it. And so for this one, substitution is going to be the best way to go. We know that y equals 6. And so in my other equation, we have a y equals 3x squared minus x plus 4. We can substitute the y with a 6. And so now we just have a quadratic equation to solve. And so we always want to put everything on one side set equal to 0. And so we would have 3x squared minus x minus 2 equals 0. And then factoring is going to be the most efficient way to solve this. You don't want to use the quadratic formula or complete the square unless you absolutely have to. And so to factor this, we need a times c, which is negative 6. And then we need our b value, which is negative 1. So we need two numbers that multiply to negative 6 but add to negative 1. And so 2 and 3 and make the 3 negative. And so we would have to split the middle with those two terms, those two numbers, and factor 2 at a time. So in this case, I can factor out an x, leaving 3x plus 2. In this case, I would want to factor out a negative 1, leaving a 3x plus 2. And so my factors are 3x plus 2 and x minus 1 equal to 0. And so we would then set each factor equal to 0. In this case, I would get x equals 1. In this case, I would get the x equals negative 2/3. Now you can't stop here. These are just your x values. Remember, we're looking for ordered pairs this time. And so we would want to take these x values and plug them back in to get the y values. And so usually I plug them into the linear. You could plug them into the quadratic, but here it's just y equals 6. And so notice our y coordinate is just always 6. Sometimes it's going to be more complicated than that. If you plug these x values into this quadratic, you'll also get 6. And so these are the ordered pair solutions, and that's how you would solve it by hand. And so for this next one, we have a quadratic, y equals 3x squared. And if I move this 5x to the other side, I will see this is y equals mx plus b. This is a line with a slope of 5 and a y-intercept of 2. And so once again, we have a parabola and a line. And so this system is going to look more like a slanted line and our quadratic. Okay, and so we're going to try to find the ordered pair solutions, but this time we're just going to use substitution. And so I like to solve both equations for y. And so in one case, I have y equals 3x squared. The other case, I have y equals positive 5x plus 2. And so we sub out the y with 3x squared, basically set the two equal to each other. And so we have a quadratic equation, and once again, we can solve it by factoring if we get everything on one side. So I would have minus 5x minus 2 equals 0. And so to factor this, I need two numbers that multiply to negative 6, a times c, but add to b, which is negative 5. And so we would want negative 6 and positive 1 here to multiply to negative 6, but add to negative 5. And so when I split the middle, and factor 2 at a time, I can factor out a 3x from the first pair, leaving an x minus 2. All I can factor is a 1 from the second pair, leaving an x minus 2. And so x minus 2 is one of my factors, 3x plus 1 is the other. When I set them equal to 0, I get x equals 2, and x equals negative 1/3. And so those are just the x values. We have to take those x values and plug them into either equation. You could go for the linear or the quadratic. I typically like using the linear. And so for the case of x equals 2, y equals 5x plus 2, we would put the 2 in for x and get 10 plus 2, which is 12. And so 212 is one of my solutions. And then for x equals negative 1/3, y equals 5x plus 2, negative 1/3 is the x. We would get negative 5/3 plus, and then we can write 2 as 6/3, which would give us a positive 1/3. And so negative 1/3, positive 1/3 would be our other solution. Okay, for this next one, we have two quadratic equations. And so I still like to solve both of them for y. So in this case, I would just add 9 to both sides. And so I have y equals 2x squared minus 6x plus 9. And then the other equation is x squared minus 10x plus 5. So once you have them both solved for y, just set them equal to each other. So I have 2x squared minus 6x plus 9, and then x squared minus 10x plus 5. And so both of these are quadratic, so we're going to have two parabolas. Both of them are going to make that U shape. Okay, and so we have another quadratic equation to solve. We're going to get everything on one side. So we're going to subtract x squared. We're going to add the 10x, and then we're going to subtract the 5. And so we get x squared plus 4x plus 4 equals 0. This is really easy to factor. We just need two numbers that multiply to 4 but add to 4. That's 2 and 2. And so x plus 2, x plus 2. And whenever your factor repeats, you don't have to set them individually equal to 0. You're only going to get one solution. And so x equals negative 2 is our x coordinate. And so we still need to get the y coordinate. And so pick either quadratic. I like this bottom one. It's going to get you the same y value either way. And so x squared minus 10x plus 5. And we're plugging in x equals negative 2. And so that would get us positive 4 plus 20 plus 5, which is 29. And so our only solution is negative 2, 29. That means these parabolas only intersect at one point. Okay, and then for the last one, solve them both for y. So I'm going to subtract 4. And I like to put them in standard form. And so this would be negative x squared. And then 3 minus 4 is negative 1. So that's one of my quadratics. And then the other is the 2x squared minus x minus 3. Okay, and so I'm going to set them equal to each other. Get it all on one side. So we're going to add x squared. And then add the 1. So we get 3x squared minus x minus 2 equals 0. And we can factor this. 3 times negative 2 is negative 6. And we need to add to negative 1. So those numbers would be 3 and 2. And we'd make the 3 negative. Split the middle. First pair we can factor out a 3x, leaving an x minus 1. Here we can factor out a 2. And so our factors are 3x plus 2 and x minus 1. And then set them each individually equal to 0. In this case, x equals 1. In this case, x equals negative 2/3. Okay, and so those are just our x values. And so for our solutions, we know one of them is going to have an x coordinate of 1. The other is going to have an x coordinate of negative 2/3. And so we just need to find the y value that goes with them. I'm going to use this equation here. And so for x equals 1, y equals negative x squared minus 1. Leave that negative outside the square. And so 1 would go here. 1 squared is 1, but we still have that negative. And then negative 1 minus 1 is negative 2. And so negative 2 would be one of my y coordinates. And then for x equals negative 2/3, y equals negative x squared minus 1. And then the negative 2/3 goes here. Negative 2/3 squared is positive 4/9, but we still have the negative outside. And then to subtract the 1, we can write that as 9/9, which would give us a negative 13/9. And so negative 13/9 would be the y coordinate for negative 2/3. And again, if I were to plug these x values into this top equation instead, you should get the exact same y values. You're not going to end up with 4 different ordered pairs. You should only end up with at most 2. And so you're not going to get a different y value if you use a different equation.